Okay, so this topic is transient when the excitation is exponential function. Okay, so here directly we will see the problem. Okay, so first you see the problem. In the series RL circuit shown in figure, the applied voltage is 100 into e power minus 50t. Find the transient current I of t. This is the question. Okay, so this is the given diagram. So what is the diagram? This diagram is a series RL circuit. Okay, here one resistor and one inductor is connected in series. Okay, the resistor value, inductor value is given, and this RL component is connected to the some voltage source via one switch. Correct? Via one switch, and the voltage source value is given as the applied voltage you see in the problem 100 e power minus 50t. Okay, what is 100 e power minus 50t? 100 is an amplitude, e power minus 50 it is a exponential signal. But you know the given input is a exponential signal. Okay, so previously the same circuit we given DC input, we given unit step input, we given impulse input and sinusoidal input. Okay, so here the given input is a exponential input. If the input is this means what is the current, what is the transient current flowing through this circuit we have to analyze. Okay, it is our question. Okay, so the procedure this remains same as that of the previous one. Okay, our first one, at a switch t equal to 0, the switch is closed. Okay, before that the switch is open, so no current is flowing in the circuit, so the initial value is 0. Okay, at a time t equal to 0, we are closing the switch. Okay, so at a time t equal to 0, we are closing the switch means, so we will get one closed path. Okay, we will get the closed path. But for this closed path, we have to apply Kvl equation. Okay, so you know the Kvl equation. So the given applied voltage is 100 e power minus 50t. Okay, so this is the voltage applied to this circuit. So this circuit it is equal to the addition of voltage drop. So what is the voltage drop across the resistor? So you know the formula, the R value into I of t. And what is the voltage across the inductor? L into di by dt. But here the L value is given as 0.5. So 0.5 into di of t divided by dt. Okay. So this is the Kvl equation. And for this Kvl equation, so here the current I of t is in here one I of t. Here in differentiation form one I of t is there. Okay. So our aim is to solve this I of t. Okay. So in order to solve this I of t, we may use the time domain method or Laplace domain method. But the time domain method is very tedious. So that's why we are using the Laplace transform method. Okay. So the next step is we have to take Laplace transform. Okay. But you see the left side. But here the constant 100 is there. So you keep the constant 100. And what is the Laplace transform of e power minus 80? So you know e power minus 80, the time exponential signal whose Laplace transform is 1 by s plus a. Okay. So here in the place of a, what is the thing is there? 50 is there. So the Laplace transform of this e power minus 80 is 1 divided by s plus 50. Okay. So which is equal to 50 into what is the Laplace transform of the signal I of t? It is a capital I of s. Right? Then plus this constant 0.5 you write. What is the Laplace transform of the differentiation of I of t? Differentiation of I of t. So you know. So according to the differentiation property of Laplace transform, one time differentiation of the function I of t can be written as s into capital I of s. Okay, minus the initial value. Okay, the previous charge. Okay, the previous current flowing in the inductor. It is said to be the I of 0 minus. Okay. So you know, so for the given circuit, there is no initial current is given. So that's why this I of 0, it becomes 0. Okay. So by next step, so you have 100 divided by s plus 50 equal to, in this term, I of s is common. So you take I of s as a common. So we have to write it as 50 plus 0.5s. Okay. So rearrange this equation. But from this equation, I of s equal to this 100 by s plus 50 and this one 50 plus 0.5s. Okay. So s plus 50 is in the structure, but here the s is multiplied with 0.5. So we have the format s plus some value. So you take this 0.5 as a common. Okay, you take 0.5 outside from this term. So we can write it as 0.5 into s plus 50 divided by 0.5. Okay, so 50 by 0.5, we have to write it as 100. Okay, then this 0.5, this denominator 0.5, in numerator 100 is there. So 100 divided by 0.5, we have to write it as 200. So the I of s equal to 200 divided by s plus 50 into s plus 100. Correct? Okay, so we will get the in this structure. Okay, so then we have to split this I of s equation as an addition of the first order functions. Okay, above in order to write this I of s using partial fraction expansion method. So in partial fraction expansion method, this I of s can be written as a divided by s plus 50 plus b divided by s plus 100. Correct? So you have to take it as a equation number 1. Okay, here this a and b, it is said to be the partial fraction coefficients. Okay, so now we have to find out the value of this partial fraction coefficients. Okay, so you know the how to calculate this a and b value. Okay, and this a is calculated by, so we may use two methods in order to calculate this a and b. One is this LCM method. Okay, you take LCM for this equation. So a into s plus 100 plus b into s plus 50 divided by s plus 50 into s plus 100, and this I of s value substitute here, denominator cancel. Then we have to equate s square term, s term, constant term. We will get ab value. Okay, that is one format. So this is the another one. It is easy. Okay, but here the a value is calculated as, so a denominator value, the s plus 50, we just multiply with the total function I of s at this root value. So what is the root value of this s plus 50? S equal to 50. Right? But here, so s plus 50 into what is the I of s value? The I of s value is 200 divided by s plus 50, s plus 100. But here s plus 50, s plus 50 cancelled. And in the remaining term, in the place of s, we have to substitute minus 50. So we will get 200 divided by 100 minus 50. So it is, the answer is 4. Okay. 50, so the answer is 4. So similarly, b is calculated as, so b ku கீழ இருக்க value, so s plus 100 into the total function, left side function I of s at s equal to minus 100. So similarly, we calculated the value, b value is minus 4. So a is 4 and b is minus 4. Okay, so we have to substitute the value of this a and b in this equation number 1. Okay, so we will get the I of s equal to 4 by s plus 50 minus 4 by s plus 100. Okay, so here you see the I of s is in the structure of 1 by s plus a structure. Okay, so we know that the 1 by s plus a is the Laplace transform of the function, the time domain function e power minus at. So we will get the answers like this. Okay, by using the standard Laplace transform pair, so we have to take the inverse Laplace transform. Okay, since here we are having the current in s domain. Okay, but we want the current in time domain. Okay, this is the transient current in time domain. In order to convert the I of s into I of t, we have to take the inverse Laplace transform. Okay, if you want to convert time domain into Laplace domain, means we have to take Laplace transform. Okay, in order to convert s domain into time domain, we have to take inverse Laplace transform. Okay, if you are taking inverse Laplace transform for this entire equation, what is the inverse Laplace transform of the first term I of s? It is small I of t. Okay, what is the inverse Laplace transform of this term? Here the 4 is constant. You keep the constant. So the remaining 1 by s plus 50. So 1 by s plus 50 inverse Laplace transform is e power minus 50t. Okay. Then similarly minus 4 into, what is the inverse Laplace transform of 1 by s plus 100? E power minus 100t. Okay. So we will get the answer. So in this, 4 is a constant. So you take 4 as a constant. So we have to write e power minus 50t minus e power minus 100t. Okay. So this is the current, transient current flowing in the given RL series circuit. Okay. So this is the current flowing in the RL circuit with respect to time t. So with respect to this time t, the current flowing in the RL circuit, it will vary. Okay. So this much. So this is the problem. Okay. The same method. Okay. So here the given source is a exponential source. So the same problem they will ask in, instead of this exponential source, there may be a just 100. That is simply 100 volt. It is a DC voltage. That is unit step voltage. Okay. Then instead of this 100 e power minus 50t, there may be a impulse signal del of t. Okay. Or otherwise there may be a sinusoidal function, some 100 into sine omega t, some 100 omega t. Okay, we solved the remaining problems. Okay, here we solved this RL circuit for exponential excitation. Okay, this is the thing. Okay, listen up. So this is the first problem. Okay, so similarly, we have to see one more problem, RC circuit. Okay, so this is the RC circuit with the input is a exponential input. Okay, so you will see the problem. You see the second problem, an exponential voltage V of t equal to 5 e power minus t is applied at a time t equal to 0 to a series RC circuit consisting of R equal to 5 ohm, C equal to 0.1 farad. Obtain the complete particular solution for the current I of t through the capacitor. Okay, this is the question. So here the diagram is not given, only question is given. Okay, but you have to see which type of circuit is this. You have to first see what is the type of circuit, series RC circuit. Okay, so first we have to draw the diagram, one resistor and one capacitor. Okay, connected in series with one switch. Okay, with one switch, and the value of resistor is given as 5 ohm and the value of capacitor is given as 0.1 farad. Okay, and this RC circuit is applied exponential voltage 5 e power minus t is applied. So the voltage source is 5 e power minus t. Okay, so what is the question means? We have to obtain the complete solution. That is, solution means here the transient current. Okay, current then the solution of this circuit. Okay, response, solution, everything is same. Okay, so we have to find out the current I of t flowing through this circuit. Okay, so the same procedure. So you know, at the time t equal to 0, the switch is closed. Okay, before that one, the switch is open, so no current is flowing. At the time t equal to 0, the switch is closed, so we will get one closed path. Okay, so let us consider current flowing in the closed path is I of t. Okay, so we have to write, what is the next step? We have to write the Kvl equation. Okay, so apply Kvl equation for this loop. So what is the Kvl equation? So first the applied voltage 5 e power minus t. Correct? So 5 e power minus t equal to, what is the voltage drop across the 5 ohm resistor? Voltage drop across the 5 ohm resistor is R into I of t. So R value is 5. 5 into I of t. Okay, plus what is the voltage drop across the capacitor? What is the formula? 1 by C integral I dt. So 1 divided by, what is the C value? Capacitor value is 0.1. So integration of 0 to t I of t dt. This is the formula to find the voltage across the capacitor. Okay, so here the I of t term is available in one in normal position, one in within the integration. So we have to solve this I of t. So in order to solve this I of t, the next step is to, we have to take Laplace transform. Okay, so taking Laplace transform, what is the Laplace transform of e power minus t? That is e power minus at means s plus a. So by s plus the a value is here 1. So s plus 1. So before that constant is there. So you keep the constant as it. So 5 into 1 by s plus 1, which is equal to 5 into I of s plus 1 divided by 0.1 into, what is the Laplace transform of integration of I of t? I of s by s. Okay, so you know, in the previous problem in RL circuit, di of t divided by dt term is there. Okay, what is the Laplace transform of differentiation of I of t? S into I of s. What is the Laplace transform of integration of I of t? I of s divided by s. That is a different. Differentiation means s into the particular term. Integration means the particular term divided by s. Okay. So when this, you take I of s as common and you have to take LCM and we have to obtain the I of s value. So I of s value like this. Okay. In this, the s is multiplied with 5. Okay. We have the term like this, s plus some value. You take 5 as common and the 5 cancelled. So we will get I of s equal to s divided by s plus 1 into s plus 2. Okay. So what is the next step? We have to write this I of s as an addition of the single order polynomial using partial fraction method. Okay. So in partial fraction method, the I of s term can be written as the constant a by the first term plus b by the second term. Okay. Okay. Similarly, if a third term is having a plus c divided by the third term, we have to write. Okay. So consider equation number 1. Okay. And you know the how to calculate the value of a and b. So how to calculate a? A is nothing but the denominator value of this a. Okay, that is s plus 1 into the left side total function I of s at s plus 1 means what is the s value? S value is minus 1. Okay. We have to multiply these two terms at the condition of s equal to minus 1. So s plus 1 into what is the value of I of s? The I of s is s by s plus 1, s plus 2. So you substitute. So these two terms get cancelled. Now you substitute s equal to minus 1. But here substitute. So in numerator 1 s is there, denominator 1 s is there. So minus 1 by minus 1 plus 2. So the answer is minus 1. Okay. Similarly, we have to find out the value of b. Okay. So the answer for a is minus 1, b is 2. Okay. So substitute the value of a and b in this equation number 1. Okay. I of s equation. So for I of s, we will get minus 1 by s plus 1 plus 2 by s plus 2. Okay. So we have in the structure of e power minus at. Correct? So e power minus at, you know the Laplace transform is 1 by s plus a. So taking, what is the next step? We have to take inverse Laplace transform. So if you are taking inverse Laplace transform for the above equation, so we will get the inverse Laplace transform of I of t is I of s is I of s. Okay. Then minus 1 you keep. What is the inverse Laplace transform of 1 by s plus 1? E power minus at. So what is the value of a? 1. Okay, e power minus t. Similarly, plus 2 into what is the inverse Laplace transform of 1 by s plus 2? E power minus 2t. Correct? So this is the current flowing in the given RC circuit. Okay, so the same procedure. Okay, so all problem in 4th unit problems ellame vandu similar procedure. You just understand the standard Laplace transform of the 5 thing. Okay, the Laplace transform of e power minus at is 1 by s plus a. Okay, the Laplace transform of u of t, that is the constant is constant by s. The Laplace transform of Laplace transform of differentiation of the particular function is the I of s into s. Okay, the Laplace transform of integration of I of t is I of s divided by s. Okay, and then sin omega t, the Laplace transform is omega by s squared plus omega squared, and the cos omega t is s divided by s squared plus omega squared. Okay, so you should remember these standard answers. Okay, so in the standard answers you should know abdina we will solve any problem. Okay, so the two problem in exponential we solved. Okay, and one more problem, again 2 problem we are going to see. This is a April May 2018 question. Okay, so the third question and fourth question is a April May 2018 question. You see, this is for DC input. Okay, DC input. So find the current in the circuit shown in figure at any instant after opening the switch. Okay, the current through the inductor was 1 amps just before opening the switch. Okay, so this is the given circuit. So in the circuit you see resistor, inductor connected in series. Okay, and with here the two supply voltages there. Okay, what is this? What is the supply? This is the DC source. This is one 12 volt battery. This is one 24 volt battery. Okay, so across this 24 volt battery there is a one switch is there. Okay, one switch is there. So in the madi nama circuit nama discuss panla. So we will see. Okay, so what is the given question? Find the current in the circuit at any instant after opening the switch. இது வரைக்கும் நம்ம switch closed means we will get the closed path, we will get the current. Okay, but here if whenever the switch is open, find out the value of current. Okay, so the question you just understand, whenever the switch is open, at that time we have to find the current flowing through the circuit. Okay, and one more thing is given, the current through the inductor was 1 amps just before opening the switch. Okay, the switch நம்ம open பண்றதுக்கு just before the current flowing in the inductor is 1 amps. So what is this 1 amps? Initial current flowing in the inductor, it is a 1 amps. Okay, appa we have to find the answers. Appa you see, appa first one we have to take it as before time, that is some time. Okay, before some time the switch was isn't closed. Because of this closed, there is some current is flowing. Okay, appa and the switch நம்ம open பண்றதுக்கு முன்னாடி and the last moment what is the current flowing in the inductor means 1 amps. So that 1 amps is said to be the I of 0 minus, that is the initial current. Okay, you note down. Okay, then so here what is our aim means, if the switch is in open condition, find the current. Okay, appa we have to open circuit the switch. So this switch is open abdina. What about the diagram? So the equivalent diagram is this 12-volt battery, and here this 20-volt battery and 6 ohm resistor, 5 ohm resistor. Okay, even though the switch was open condition, we will get the one closed path. So in this closed path, the two batteries are connected in some series manner. So here 12-volt battery, here 24-volt battery with RL circuit. Okay, so what is the next step? We have to write the KVL equation. So what is the KVL equation for this one? What is KVL? The algebraic sum of என்னப்பா? ஹலோ, என்னடா கேக்கலையா? மா கேக்குதா அருணாதேவி?